Welcome back. We're looking at the scientific method, and before the break we were looking at making observations, asking questions, working through how you make a hypothesis, how you state a hypothesis, drawing up your experimental design, and finally conducting the experiment. Now, once you've conducted your experiment, you have a series of results. Your results, maybe you made measurements, maybe you took photographs, maybe you collected data, and what do you do with it? It has to be organized in some way. You need to possibly make up tables or charts. You need to somehow put your data together so that other people can look at it and recognize what you have achieved in your experiment. So, getting back to our example of your coffee, if you did an experiment that looked something like this. You had sugar and water in identical amounts, but in setup A, the water was cold. In setup B, the water was heated to 30 degrees, C, the water was heated to 60 degrees, and D, the water was heated to 90 degrees. And you decided to pour sugar into the water at these different temperatures to see how much would dissolve. You now have a whole set of results. The best way to present these results is possibly putting it into a table. And so you can see that on the right-hand side of this table, we have the amount of sugar that was dissolved in each of those beakers. And you can see very clearly when you put it into a table that certainly more sugar dissolves when the water is hotter. And so you are now in a position where you can start saying, I know why my coffee wasn't sweet that day, because the water had got colder, and so the sugar possibly just fell to the bottom of the mug and it didn't dissolve properly. So you now have a set of results that you can draw some conclusions from those results. You're in a position where you can make deductions, you can deduce things. You can say, if those are the results, I think that the temperature of the water, for example, does influence how much sugar can dissolve in it. And so you can use those results to answer the question that you asked, and you can apply that back to your hypothesis. You're going to have to use skills of explaining and reasoning. And finally, at the end, you're going to say, well, was that the best possible test for answering my question? Or next time, should I maybe include different temperatures, maybe iced water, as well as just cold water? And so you can start to evaluate your investigation. That is a hallmark of a very good scientist. If you can look at all this work that you've been doing and not just say, oh yes, it's wonderful because I've got to the end of it, but if you can look at it critically and say, these things need to be improved, or I made a mistake with my experimental design and I actually have to go back a few steps and I have to redesign that experiment because it didn't work as well as what I thought it would work. Those are important things that you as a scientist have to do. Very often you will get a test question or an example of something like this in an assessment work where you have to look very carefully at an investigation and see what was wrong with this. How could it have been made better? And you're going to look at the variables, for example. We've spoken about that. You're going to look at the design process. And you're going to have to evaluate the way in which the experiment was done in order to make sure that once you have these conclusions and results and everything you've got to the end, do these conclusions support the hypothesis? That is ultimately where the scientific method ends up. And that is testing the hypothesis. You made a statement that you thought answered your question. Now, do your conclusions support that hypothesis? Are you going to accept that hypothesis or are you going to reject it? So, you had the situation, for example, where you had the yellow grass under the brick. You can say, I think, and this was your hypothesis, that that patch of grass needs more water. And so you did your experiment, and for 2 weeks you kept the brick, but you watered that patch of grass far more. And when you removed the brick after 2 weeks, the grass was still yellow. And in that case, you've got to say, no, it didn't need more water. I have to reject my hypothesis. I have to find out something else, because what I originally thought was correct is not correct. At the end of my series of tests, I have to reject my hypothesis. Now, should you feel sad about that? Should you feel worried that you're a failure? After the break, we'll confirm whether you're a failure or whether you're actually a very good scientist.